It is surprisingly common to see chimpanzees dressed up in little outfits, paraded around on television, or even kept in suburban homes like furry children. But beneath those human-like expressions is a creature built for a fiercely competitive environment. They are wildly dangerous apex survivors. This diagram compares human and chimpanzee muscle fibers. Humans average 40% fast twitch fibers, used for explosive energy, while a chimpanzee boasts 67%. Because of this dense setup, a chimp generates 1.5 times more force than a human of the same weight. That raw power backs up a lethal weapon. Males develop enormous, razor-sharp canine teeth, designed specifically to shred through the flesh of rival apes during a fight. Expecting this animal to act like a docile toddler completely ignores millions of years of specialized predatory evolution engineered for brutal physical survival. Yet looking at them can still feel like staring into a funhouse mirror. Despite those terrifying physical differences, humans share 98.8% of our DNA with chimpanzees. We also share a capacity for calculated warfare. Chimps form political alliances, establish borders, and execute organized patrols to ambush and brutally eliminate members of neighboring groups to expand their territory. That complex brutality even extends to resources. When scientists taught captive chimps to use tokens to buy fruit from a vending machine, the apes quickly grasped the concept of currency. Within days, they began hoarding the tokens, eventually fighting each other to steal the stash. They clearly possess sophisticated social networks and economic instincts. So why do they spend their lives swinging through the canopy while we build global supply chains? That remaining 1.2% genetic difference represents a massive evolutionary fork in the road, sending our two species on vastly different biological trajectories. For a long time, researchers assumed humans were uniquely gifted with theory of mind, the ability to understand that other individuals hold different beliefs and knowledge from our own. But modern tests prove chimps actively track what their rivals can and cannot see when competing for food. In some cognitive arenas, they actually leave us entirely in the dust. Researchers recently pitted adult humans against 5-year-old chimpanzees in a test of short-term working memory. This visualization shows the test layout. Numbers 1 through 9 appear randomly across a touchscreen. Subjects must recall the exact spatial order, even when numbers flash for just 210 milliseconds, less time than the human eye needs to scan the frame. The young chimpanzees clear the board with speed and precision. They utilize a type of eidetic memory, taking an instantaneous, flawless mental photograph of the screen that completely outclasses human working memory. When it comes to pure, raw processing speed of visual environments, the human brain is biologically inferior to a young chimpanzee's. Evolution operates on a strict budget. The brain requires immense amounts of energy, meaning a species cannot maximize every single cognitive trait at the same time. Chimpanzees spent their neural budget on eidetic memory to instantly map the complex forest canopy, rapidly locating precious fruit and identifying threats to survive. Humans took a different path. About 500,000 years ago, our ancestors developed a mutation in a specific gene known as FOXP2. The FOXP2 mutation bridged declarative memory for facts and procedural memory for automatic routines. Linking these regions let humans turn abstract sounds into locked-in visual associations. Hearing a word now instantly summons its image. This mechanical link is the foundation of spoken language. Speech required vast amounts of neural real estate. Gaining the ability to communicate forced our brains to sacrifice the exact wiring that gives a young chimpanzee its photographic recall. That physical trade-off defines our existence. Humans sacrifice the explosive, fast-twitch muscle fiber of an apex predator to biologically support a brain heavily optimized for communication. We abandoned the ability to instantly memorize our physical environment, prioritizing the brain space needed to build extensive vocabularies and intricate syntax. The evolutionary result is a physically weaker, slower species that survives entirely by relying on complex collaboration to outsmart its environment. A chimpanzee never made those traits. They optimized their biology for raw individual physical dominance within their immediate territory. They do not need language. Their lack of speech points to a highly successful biological strategy that prioritizes lethal physical power and immediate spatial processing over conversation.
It is easy to look at our close genetic cousins and imagine they are evolutionary stepping stones, waiting for the gift of language to catch up to us. But they are exactly where they need to be. They sit at the absolute pinnacle of their own distinct evolutionary branch, silent, brilliant masters of their ecosystem. We shouldn't look at chimpanzees as a species we need to tame or elevate, but rather respect them as a deeply specialized parallel mind we can never